Today, we're going to do words, equations, tables, and graphs. Words, we're going to be writing words into equations. We're going to take those equations and make tables out of them, and those tables we're going to use to make graphs. So we're going to use each one of these. One thing you need to know is a function rule is the operation or operations performed on the domain value to get the range. Remember, domain was always your x coordinates. Range is always your y. Another word for domain is input. Another word for range is output. So they give us our input, we plug it into the function rule, the equation, and then we get a range value or we get an output. So what they're going to do is they're going to give us something like this. Words that describe an equation. Double a number, then add 3. So I'm going to do 2x plus 3. Double number is timesing it by 2 and then adding 3. Then they're going to give us some numbers, our input, we plug them in, we get our output. Any questions so far? Alright, what you need to do is you need to write down page 34 in your book, example 2. Write that down. Okay? What you see here on the board is on page 34, so you need to open your book to page 34. I'm trying to save you some writing. Instead of writing out this problem and all the questions, I'm just going to have you refer to that question in your notes, and whatever else I write down, you write down. Because we're going to answer A and B for the example number 2. Example 2 says the navigation message from a satellite to a GPS in an airplane is sent once every 12 minutes. Question A says write an equation to find the number of messages sent in any number of minutes. Here's how I do it. Here's the easiest way. If I'm not for sure what they're asking for, I start like asking myself some questions. For me, what I would say is, all right, how many messages are sent after 1 minute or after 12 minutes? What does it say? It says it sends a message every 12 minutes. So after 12 minutes, how many messages are sent? 1. After 24 minutes, how many messages are sent?
2.
After 36 minutes, how many messages are sent? 3. So does everybody see a pattern here? What I'm doing is I'm taking the number of messages. Okay, I find that by taking the number of minutes, which I'm going to call T. I divide that by 12, and that gives me my number of messages. We're going to call it N. So I take the time divided by 12, because 36 divided by 12 gives me 3. That's the number of messages. So this is my equation. That's how I find it. It's just by answering some simple questions about it. Anyone have any questions yet? Okay, so you should have wrote A, and then you should have wrote T over N, or T over 12 equals N. Here's going to be our answer for B. B says make a function table to find the number of minutes and messages from 120, 180, 240, and 300 minutes. And then graph the order pairs. So what I want you to write is B, like that. And now we're going to make a function table. So for my function table, it's got to have an input, which is my T. Then I've got to have my function rule, which is what the function I came up with, which is T divided by 12 equals N. And then I've got my output, which is N. So I want to make a table that looks just like that. And you can see, okay, on page 34 in your book, they've already done that for you. But we're going to go ahead and fill it out just so you have the practice of filling out one of these tables. So my input is what they give me, which is 120, 180, 240, and 300. Okay, and then my function is T divided by 12 equals N. So I'm going to plug in my 120 for T. So 120 divided by 12, which what is 120 divided by 12? 10. Then I want to plug in 180. 180 divided by 12 is what? Does anyone know? 15. 240 divided by 12 is 20. And 300 divided by 12 is 25. Now that I've got this function table, I'm going to go and graph the ordered pairs. Which, I just want to make a small comment. On some of your homework, it's not going to say graph it. Instead, what it's going to say is state the domain and range. What would be my domain here? The input, my x, right? My input. So I would write domain above this. If you look, okay, the book does it separate. It writes D out to the side, and then once you write 120, 180, 240, and 300. I don't care if you do that or if you just write domain above the input. What would be my range? The output. That's the same thing to me as doing this. Okay? I don't care if you do this or if you do that. I would do that since you already have to make a function table. Any questions? Now, let's graph these ordered pairs. I'm not going to make you show this in your notes because it's already in the book, okay, graphed. So I just want you to pay attention and follow along as I do this. Now, here's one thing. If you look at your ordered pairs, which is going to be 120 and 10, 180 and 15, 240 and 20, do I ever have any points that go here? Is there any negative x coordinates? Are there any negative x coordinates and negative y coordinates? Am I ever going to put anything in here? So I'm pretty much just going to use this little quadrant right here, right? That's a lot of space that's wasted. So what I like to do is I like to get rid of this x and y axis and label this as 0 and that as 0. So now I have a new x and a new y. I make this right here from that. And then I'm going to scale it because would 120, 180, and 300 all fit on this? No. So I have to scale it anyway. So I'm going to make it the way I want it. So for my x's, like I said, it's 120, 180, 240. What would I want to go by? Do I want to go by ones? 1, 2, 3, 4, 5. Go by twos? 2, 4, 5, 2, 4, 6. What do you think? 20s? I would go probably with 20s. Okay? If you go by 10s, you're not actually going to make it to 300. Okay? Because this would be 100, this would be 200, and I need all the way to 300, right? So you could go 20s. So this would be 20, the next one would be 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300. Now I'm not labeling every one of these because I'm trying to save myself some time. Okay? You can if you want, but it's a lot of wasted space to me. So now I've got my x-axis labeled, right? What do I need to put my y's in? Should I go by 1s? Should I go by 2s? Okay? Well, let's look at what my y's are going to be. My output is 10, 15, 20, and 25. If I go by 1s, would I meet this? Will I go all the way to 25? So I have to go by at least 2s, right? Okay, and that's what I'm going to go. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 30. Okay, any questions? This actually, I was off one. I thought I did something wrong. The first one should be 0, so this is 2, 4, 6, 8, 10. Okay, I was off one. Everybody see what I've done? Now, can I correctly put these ordered pairs on this graph? Okay, and is it spaced out to where I can easily read what I've got? Yeah. Imagine if I put it here. Okay, it would be pretty grouped together. I wouldn't want it like that. I don't want it lumped together. All right, so the first one is 120 and 10. So 120 and 10. My second one is 180 and 15. So I have to go between 14 and 16. And it goes right there. My next one is 240 and 20. My next one is 325. Does that make sense? Okay. And you can see it's going in a pattern. It's going like that. Okay. If one of these is way off, I'm probably wrong, right? Okay. Any questions on how to do that? All right. This is the second example for number 2. So I want you to write page 34, example 2.2, because it's the second one. It's right underneath the one we just read. Again, I'm trying to save you from writing it all. So if you have any questions about why you wrote down these certain notes, you can go back and look and say, oh, okay. For A, here's what the equation I'm going to write. Now it says the speed of sound is 1088 feet per second. It says write an equation to find the distance traveled by sound for any number of seconds. The easiest thing for me is to answer some small questions about this. Like how far would I have traveled if I went 1 second? What would it be? After 1 second, it'd be what, Kurt? 1,088 feet. If I've traveled this for 2 seconds, how would I find how far I've traveled? What?
Multiply by 2.
I would times it by 2, right? What about 3? I would times it by 3. Does everybody see a pattern here? So my equation, I would say, for A is 1088 times x, which x would be the number of seconds. So if I want to find out how far I traveled, I just times it by the number of seconds. Isn't that what we did? 2 times 1088, 3 times 1088. So that's my answer to A. Now, here's the full question, right, which we don't need to know. Here's B. Make a function table to find the distance sound travels in 0, 1, 2, 3, and 3 seconds, and graph the word pairs for the function. So let's make that table. Now here I'm just going to go with x, and I'm going to go 1088x, and then I'm going to go y. My x would be my input, my y would be my output. It'll also be my domain and my range. My input is 0, 1, 2, and 3. I'm going to do the first one for you, and then you're going to finish the rest. You're going to finish this table. So, what would be 1088 times 0? 0. Now, I want you to figure out the rest. Alright, so make sure you have written down what I'm going to write down to make sure you did it right. 1088 times 1 is 1088. 1088 times 2 is 2176, right? Everybody got that? And 1088 times 3 is 3264. Am I right? Is that what everybody else got? So now we're supposed to graph those ordered pairs. Now if it doesn't ask you a graph, it'll probably say state the domain and range. This would be your domain, this would be your range. Alright, make sure you follow along. I'm going to scale this just like we did before. I'm going to make this 0 and that 0. So I have complete new axis. That's x and that's my y. Because I want to use the whole graph. Alright. What should be my x coordinates? Look at your table there. What are your x coordinates on the table? 0, 1, 2, 3. So would I want to go by 2s or 5s on this? No, that's going to be all crunched together. I also, in just my opinion, I don't want to use 1, 2, 3, 4. And here's why. I'm going to use this amount of space and not use any of this. So here's what I'm going to do. I'm going to make each line a fourth. And so every 4 lines is going to be 1. So a quarter, a half, 3/4. Here's 1. A quarter, half, 3/4. Here's 2. And there's 3. Now am I using more of this graph? Yes. It's also going to be spaced out a whole lot better. What about my y's? What coordinates do I want to go with my y's? What are my coordinates for y? What do I have to have on there? 0, 1088, 2170. So what do you think I want to go with? If I went by hundreds, would I make it all this way? No, I wouldn't. Okay. Well, yeah, maybe. What's even less than that? Or how about 200s? Let's see if 200s go. 2, 4, 6, 8, 1,000. 2, 4, 6, 8, 2,000. 2, 4, 6, 8, 3,000. Am I using the majority of this graph with 200s? And that's what I want to go with. So 200. That 200, I promise. Sorry, it's hard to write. 2, 4, 6, 8. That's 1,000 right there. 2, 4, 6, 8. That's 2,000. 2, 4, 6, 8. 3,000. And that right above it is 3,200. Alright, so now let's graph it. So my first x is 0. What was my first y? 0. So I'm going to put a dot at the origin. We call this the origin, 0, 0. Next is 1 and what? 1, what's my y coordinate? 1088. So I'm going to go just above 1,000. Right about there. 1088. Do you think I care if it's perfect? No, it's not going to be. It's not going to be exact. That's okay. 2 is what? 76? 2176? So 2176. So I'm going to be just below that second line, that line right above 2,000. What about 3? What was I at? 3264. So I'm going to be just above 3,200. So right about there. Does this look kind of like a line? So I must be doing it right. Okay. If it's not, I'm either doing it wrong or it wasn't graphed right. Well, so you're going to be doing it wrong. Okay. Most of these are going to be lines today. Any questions? So everybody understands how to read the words and to make an equation. Make the equation into a table and make the table into a graph. Everybody got it? All right, here's your assignment.